Hello, geometry students. In this lesson, we're actually going to solve real-world problems or manufactured real-world problems using trigonometry. Remember, trig functions are just numbers. If you have the sine of an angle, it's equal to the opposite over the hypotenuse. If you have an angle that you want to find the cosine for, you will find the measure of the side that is adjacent or attached and divide by the hypotenuse. Finally, the tangent of an angle is the length of the opposite side divided by the length of the adjacent side. Just remember that all these are just numbers. They're just lengths of a triangle that you just need to measure and divide. So before we get started, I want to talk about two things called the angle of elevation and the angle of depression. If you look at this, the angle of elevation is above the horizontal. And of course, what you can see eventually is that you will be able to make some sort of right triangle with that, and that will be the angle you'll be looking at. Likewise, there's something that's called the angle of depression, which is an angle that's below the horizontal. And again, you'll be able to make a right triangle with that. If you're at opposite ends, these two angles will be the same. We're looking at the angle of depression and then the angle of elevation because it's looking up. Don't be confused, just because this one's lower down, it's still an angle of elevation. And these two angles are going to be congruent. And then, of course, I said why, and that's because you have parallel lines cut by a transversal, and these are alternate interior angles. So alternate interior angles is what makes these two angles the same. So with that in mind, this first thing is just asking to identify angles of elevation and angles of depression. Angle of elevation, of course, goes up from the horizontal. Angle of elevation goes up from the horizontal. And then angle of depression is looking down from the horizontal. Again, don't be confused about the location. You can be up, you can be down. Any one of them, you just have to know that you're looking up. And it really comes when you're constructing the problem. Like, for example, on this one. It says you're standing 25 feet from the base of a flagpole. There's the grass. Here are you. Actually, technically, maybe you're laying on the ground. And you have an angle of elevation up to the top of the flagpole of 60 degrees. The angle of elevation is above the horizontal. Then they also tell me that this is 25 feet. This is a classic. I'm trying to find the height of this flagpole. I'm going to sketch a triangle. So what I have is, I have 25 here, I have 60, and I'm trying to find, the first thing I always like to do is identify the hypotenuse. This is the hypotenuse. I am not going to be using the hypotenuse. So I need to come up with a trig function that does not use the hypotenuse. Well, remember, Oscar had a heap of apples, sine, cosine, tangent. The only one that doesn't use the hypotenuse is the tangent. So to do this problem, I'm going to use the tangent of an angle is equal to the measure of the opposite side divided by the measure of the adjacent side. All right, well, let's fill it in. The tangent of theta, which is just a number, it's already in my calculator. I can even go ahead and figure out what that is now. Forgot to put the number in. Excuse me. The tangent of 60 is equal to the square root of 3, but really I like 1.73. I'm going to reserve that number. It's equal to the length of the opposite side. So if you're standing here, the height is on the other side and the 25 is adjacent. So it's height divided by 25. And if you watch the previous videos, I said that if ever the variable is on the top, that's when you multiply. So the answer to this problem, you always write the number first, and then you write tangent of 60. What I really did was I multiplied both sides by 25. Well, again, tangent of 60 is just a number that a lot of times I won't even know what it is. A lot of times I'll just put that 25 tangent 60 in my calculator. And I get my final answer of 43.3. It's feet, but before I put a box around it, I'm going to at least see if I'm in the neighborhood. You can't be sure about this because you've drawn the picture yourself, but at least it doesn't seem crazy. That is the answer. And that, of course, is one of the most ancient trig problems, is finding the height of some sort of structure. Here we're using a flagpole. Well, look at number 2. If you weren't looking at the picture, it says a kite string makes an angle of 57 degrees with the ground. 100 feet of that string has been let out. How high is the kite? Well, I can't climb up the string to measure the height, but I can create a right triangle. And I know that it makes a 57-degree angle with the ground, and that 100 feet of string has been let out. And I'm trying to find the height. So draw yourself a picture. I'm trying to find this height here, or altitude. So again, my triangle looks like this. So I'm standing at this corner here. I'm going to identify my hypotenuse always first. That's across from the right angle. And now I need a trig function that relates the hypotenuse that I know and this side that I don't know, which is on the other side, making it the opposite. So opposite and hypotenuse. Opposite and hypotenuse is obviously going to be sine. The other two do not use the information that I need. So I'm going to use the sine of this angle is equal to the measure of the opposite, which is actually what I want to find, over the measure of the hypotenuse, which I already know. So the sine of 57, which is just a number, is equal to opposite, which I'm trying to find, over hypotenuse, which I know. There's the formula. Whenever the variable is on the top, you multiply. Write the number first and then write the trig function. You can put that in your calculator directly, but I just want to emphasize that sine of 57 really is just a number that you would used to look up in the back of a book, but now you can just do it on your calculator. And then multiply times 100, and you have 83 point, we're going to call it 9 feet. Now, before I put a box around it, I'm going to check, does this seem reasonable? If you have a 57 degree, the 100 is the hypotenuse, it doesn't seem unreasonable, so I'm pretty content that that is my answer. The method is just to go through, draw a picture, figure out the trig function, and then set it up. So I'm going to do the same thing on this one. I'm going to sketch a picture, I'm going to read it, sketch a picture, figure out the trig function, set it up, and solve it. You're standing 45 feet from the base of a tree. Your eyes are 5 feet above the ground, and you sight the top of the tree at an angle of 47 degrees. So you're standing here, your angle of elevation is 47 degrees, and you are 45 feet from the base of the tree, and I'm trying to find out the height. Notice on this one I've got an extra 5 feet. That does not include it in my triangle, so that the last step is going to add that 5 feet because my eyeballs are not on the ground. If you want another picture, your angle is here. Your x, or height, is here, and you know that. So I need a relationship. First thing I need to do is identify the hypotenuse. I'm not going to use the hypotenuse because I don't know it and I don't want it. So I need to come up with a trig function that uses the side that is adjacent and the side that is opposite. I don't want to use the hypotenuse, so I can't use sine, I can't use cosine. I'm going to use tangent as the only option that does not involve the hypotenuse. So tangent of an angle, which is just a number that's already been determined by the ancients, is equal to the length of the opposite side over the length of the adjacent side. Whoops, I'm writing the formula here. So fill it in. Tangent of 47, which is just a number, is equal to the length of the opposite side, which is my variable in this case, and the length of the adjacent side. When the variable's on the top, it's when you multiply. So I am going to multiply 45 times tangent of 47. I'm not even going to bother figuring out what that is. That's 48. That's the answer, but not entirely. I have one more step, and that is I need to add this 5. I found this distance here is 48. I still need to add 5 to it. So the total height is equal to 48.3 plus that 5 feet off the ground for a total of 53.3 feet. And that's that.